So welcome to the channel Pharma for You. So today in this video we are going to cover some questions. Students, if you are watching the video first time on our channel, so please subscribe and hit the bell icon on our channel, because we are coming more videos of various topics which we're gonna help you in your Gpat exam and in your competitive exam. So here we have a first question of this video is that which of the following drugs should be used for emergency treatment of heroin overdose? That which drug is used for the treatment of heroin overdose, students? And the options are: option A is naltrexone, option B is pentazocine, option C is dextromethorphan, option D is naloxone. So which is the correct answer, students, and which drug is used for the treatment of heroin overdose? And the correct answer is naloxone. Naloxone is used as an emergency treatment of heroin overdose. So let's talk about with the help of explanation. So here we have explanation that naloxone is an opioid antagonist used for the acute overdose and chronic addiction, where naltrexone is an opioid antagonist used for alcohol addiction and opioid addiction. Students, just try to note down that it is used for the alcohol addiction and opioid addiction. Next one is pentazocine. Pentazocine is an benzomorphin mixed agonist antagonist, narcotic analgesic, and dextromethorphan is morphine and antitussive. So students, just try to note down each and every drug with their specific properties. So moving on the next question, that Gibbs phase rule for the general system, we have to tell about the Gibbs phase rule, and the options are P plus F is equal to C minus 1, option B is F is equal to P minus C plus 1, and option C is F is equal to P minus C plus 2, option D is F is equal to C minus P plus 2. Students, actually we had this studies in first year in inorganic chemistry. So what is the Gibbs phase rule? The Gibbs phase rule is the F is equal to C minus P plus 2 for the general system. So let's discuss about some information about the Gibbs phase rule. Here we have just general information about the Gibbs phase rule, that Gibbs phase rule is a method for determining the least number of intensive variables that can be changed without changing the equilibrium state of the system. And it is the phase rule is used to study and understand the way that the temperature, pressure, concentration, etc. affect the phase of a substance. Means temperature, pressure and concentration and various other substances can be noted which affect the phase of a particular substance. And the Gibbs phase rule for general system is F is equal to C minus P plus 2. You can also learn like that, FCP plus 2, and where F is number of degrees of freedom and C is number of components, and P is the number of phases in thermodynamics equilibrium with each other. Another information, next information on this, that what is phase? First of all, phase. A phase is a consistent, physically distinct segment of system that is separated from other segment of the system by binding surfaces. And what is degree of freedom? It is an intensive variable that must be known to describe the system completely. Example, temperature, concentration, pressure or density, etc. So students, and talking about the component or chemical entities, that it is a constituents by which the compositions or makeup of each other things. So it's all about the Gibbs phase rule. So what is Gibbs phase rule? That F is equal to C minus P plus 2. This is the Gibbs phase rule. So moving on the next question, that with which of the following test can be alkaloid of deadly nightshade leaf can be identified. So options are, option A is fluorescence test, option B is Thalioquine test, option C is Gray's test, option D is Vitale's test. So which of the following test can the alkaloids of deadly nightshade leaf be identified? And the correct answer is the Vitale's test. So let's discuss about this with the help of explanation, that what is Vitale test. Actually, Vitale test is for the tropane alkaloids. Tropane alkaloids. And it is used for the identification of deadly nightshade leaf. Deadly nightshade leaf, actually the synonyms of Atropa bellodona. Atropa bellodona is a tropane alkaloid and it has having the synonym is deadly nightshade leaf. And the chemical constituents of this is atropine, hyoscine or hyoscyamine. So Vitale test is for the bellodona or tropane alkaloids, that is deadly nightshade leaf. Coming on the next test, that what is Gray test. Gray test is dry distillation. In this, heating in a test tube of cinchona bark. Just try to note down that Gray test is for cinchona bark containing cinchona alkaloids or the salts of cinchona alkaloids, and carry distillate to the red to the purple color. It is the result, students, that red color changes to the purple color, or red or purple color is formed as a result. So Vitale test is for tropane alkaloids and Gray test is for cinchona. Next is fluorescence test. What is fluorescence test? It is used for quinine or quinidine. And what actually in this test, it includes, if we just take quinine plus oxygenated acid, then blue fluorescence in a daylight at in a UV at 254 lambda max, that is nanometer, and intensifies on dilution. Next one is Thalioquine test. Thalioquine test is for quinine, that it is having the actually students, it is for the cinchona. So cinchona having chemical constitution quinine or quinidine, and in this test we take bromine water plus strong NH4OH. Sometimes students, the question may also ask that which Thalioquine test is used for which drug, that the correct answer is cinchona. And what color actually produced? The color is emerald green color. Then note down that in Thalioquine test the emerald green color produced. Now next question is that which of the following plot indicates the effect of antagonist on receptors. Options are Michaelis-Menten equation plots, option B is Lineweaver-Burke plots, option C is displacement plot, option D is skilled plots. So which of the following plot indicates the effect of antagonist on receptor? And the correct answer is skilled plots. So let's discuss with the help of explanation, that actually first we have to understand that what is the Michaelis-Menten. Michaelis-Menten actually are used to study that how the rate of enzyme catalyzed reaction and is affected by substrate concentration. So it is related to the enzyme and substrate concentration, where Lineweaver-Burke plot is used to determine that whether an enzyme inhibitor is competitive or non-competitive. Students, try to note down that Lineweaver-Burke plot is used to determine that an enzyme inhibitor is whether a competitive or non-competitive in nature. And displacement curves are used to measure IC50 values for receptor antagonist. Next one is skilled plot, which is the correct answer, that are used to study the effects of antagonist on receptors, and it is double logarithm plot of log, that is concentration ratio of agonist to antagonist is -1 on y-axis against log, that is antagonist concentration on x-axis. So students, it's all about this question. Moving on the next question, that allopurinol can inhibit the metabolism of And the options are cisplatin, option B is doxorubicin, option C is mercaptopurine, option D is 5-fluorouracil. So allopurinol can inhibit the metabolism of mercaptopurine. So let's discuss with the help of explanation that first, allopurinol is an anti-gout drug, and what is mechanism of action? Actually, it inhibits the enzyme xanthine oxidase. How will it inhibit the enzyme? Let's discuss that. It's an hypoxanthine. Hypoxanthine converts into the xanthine, and xanthine converts into the uric acid. So how will it actually, in presence of xanthine oxidase, it converts, the first is hypoxanthine. Hypoxanthine converts into xanthine with the help of xanthine oxidase, and again xanthine converts into uric acid. So allopurinol inhibit this xanthine oxidase. So this enzyme is responsible for the oxidation of xanthine to oxidation of xanthine and hypoxanthine to uric acid, as we already explained to you. And allopurinol inhibits the uric acid formation. So 6-mercaptopurine is metabolized by the xanthine oxidase, and xanthine oxidase to 5-methyl mercaptopurine. At last, allopurinol inhibits the metabolism of 6-MP, and hence when allopurinol is used with CMP, then dose should be reduced to 1/3 or 1/4. So students, I hope that you have just clear mechanism of allopurinol, that it inhibits the xanthine oxidase and enzyme. Now next question is, which of the following combination should be avoided? Options are, option A is P is rifampicin or oral contraceptive, option Q is tolbutamide and sulfonamide, option C R is levodopa and vitamin B6, option S is chloramphenicol and phenobarbital, as well as erythromycin and carbamazepine. So which is the correct answer? So the correct answer is PQRS, means these are always avoided. That is PQRS, means they are not used as a combination. So let's discuss each and every point with the help of explanation. First, rifampicin and oral contraceptive. That oral contraceptive contains estrogen and progestins, and rifampicin it is an enzyme inducer, students. It is an enzyme inducer and metabolizing, so leads to the decrease in metabolism. So thus rifampicin may impair the effectiveness of estrogen, and menstrual disturbances are also noted with this combination. Coming on the next one, tolbutamide and sulfonamide. So sulfonamides may impair hepatic metabolism of sulfonylureas such as tolbutamide. So tolbutamide is a sulfonylurea class and alter their plasma protein binding. So in the co-administration of sulfonylurea and sulfonamide, sulfonylureas have increased half-life. So hypoglycemic may occur, means decrease in the blood glucose level. So thus it require monitoring of blood glucose level and decrease sulfonylurea. In a very short form, the use in combination leads to the decrease in hypoglycemia. Hypoglycemia means glucose level decrease. Glucose level decrease. Next is chloramphenicol and phenobarbital. So the liver metabolism of either chloramphenicol or barbiturates may be changed, and chloramphenicol effectiveness may be reduced due to decreased serum level, while barbiturates effects may be enhanced. So effects may persist for days after barbiturates are withdrawn, and management requires increase in chloramphenicol dose and monitoring plasma level, as perhaps lowering barbiturate dose. So students, all the combination are avoided. So it's all about this question. Moving on the next question, that match the drugs with their suitable mechanism of action. Option, here we have just mentioned the drugs and their mechanism. So here we have just options, we have to match them with their mechanism of action. Here we have options. So actually which option is correct? So after studying, the correct answer is, so let's discuss, means P means P to 2 means terbinafine having, it is act as a selective inhibition of squalene epoxidase, and pseudofovir is inhibition of DNA polymerase, and imatinib is a tyrokinase inhibitor, where stavudine is the inhibition of a reverse transcriptase. So students, try to note down these short points. Here we have just explanation. It is an inhibitor of squalene epoxidase, terbinafine. Pseudofovir is an inhibition of DNA polymerase inhibitor. Imatinib is a tyrokinase inhibitor, and stavudine is an inhibition of reverse transcriptase. It is an antiviral drug. So students, next question is that Carr's compressibility index gives an idea about the flow property of powder, cohesiveness of powder, both or none. So Carr's compressibility index gives an idea about the flow property of the powder or cohesiveness of the powder. Now the next question, Kelvin equation is related to the particle size analysis, pore size analysis, or surface area analysis, or sedimentation. So Kelvin equation is related to the pore size analysis. So students, try to note down that Kelvin equation is related to the pore size analysis. Now the next question and last question of this video, that according to IPBP, very fine powder is one of which all particles pass through 120 number sieve, or 90% particle pass through 350 sieve. Option C is all particles pass through 350 sieve. Option D is 90% particles are of size greater than 10 micrometer. So the correct answer is that all particles pass through 120 number sieve are very fine powder. So students, I hope you just liked this video. So please subscribe and hit the bell icon for getting more updates on our upcoming videos for your competitive exam. Thanks for watching.